We are very fortunate to have many great speakers here today. And our speaker today to talk about blockchain, a kill chain, is Dr. Jim Treinen. Dr. Jim Treinen is Carbon Black's Vice President of Threat, a security industry veteran with 15 years of experience. Jim is based in Boulder, Colorado, and is responsible for original threat research and operationalization of threat intelligence. Additionally, he leads the team in charge of publishing research findings and emerging trends as they pertain to the cybersecurity industry. As a holder of a PhD and MS in computer science with a focus on machine learning and graph algorithms, Jim is an expert in data analysis related to enterprise security. So could you please give a warm welcome to Jim?
Thank you. Thank you. I'm happy to be here today. It's great to be back in Australia. So today I'm going to be speaking about the subject area of security analytics. This has been a hot topic in the security industry for about the last 10 years, as how I actually got into the security business. I started out doing business intelligence work for IBM and saw the opportunity to switch into security. And so I'm going to just discuss a little bit of the lessons learned that I've had over the course of the last 15 years of my trying to tackle the security analytics challenges and trying to propose a framework of how to think about this. There's a lot of hype in the industry about different applications of machine learning and artificial intelligence and whatever is coming next. And so my goal here is to basically give an overview of the problem and then talk about a proposed framework to think about the topic of security analytics moving forward. So a little background about myself. I am the VP for Threat at Carbon Black, which means that I get to sit in an organization that is a sister organization to our core product engineering group. And so we have product engineering, which builds all of our platform and all of our endpoint technology. And my group is actually responsible for all the analytics tech that goes into both our endpoint and the cloud-based analytics that actually drive the detection and prevention efficacy of our product line. So I started my career at IBM in the business intelligence world and then transitioned into IBM's security business and worked with IBM Zurich Research Lab and wrote my doctoral dissertation on applications of machine learning and behavioral analysis to post-processing SOC alarms. Moved on from that after 10 years at IBM, went into the startup world. I worked at a crypto company called Laconic, ran the research team at ProtectWise, which is a full packet capture network forensics tool and detection tool, and then transitioned into Carbon Black about 2 years ago. So the goal of my talk today is just simply to introduce concepts, right? I'm going to talk about the different things that we can apply to the realm of security analytics and propose a framework to put them in, hopefully answer a few questions at the end, and hopefully you can leave here knowing a little bit more about what's a pretty complicated topic. I'm not going to go through the math. I find that that's boring as hell to most people, so we will not do death by equation today. I'm not going to pitch Carbon Black, and I'm not going to propose any silver bullets because there's no such thing. So this is the requisite hacker slide, but I put this in here because I think it's very important to understand that a lot of times when we're dealing with doing defensive security that we're actually up against people, right? There's a lot of automated spray and pray type of attacks that go out there. There's a lot of worms and things that are code-based, but we're oftentimes dealing with people that actually have their fingers on the keyboard. They're smart, they're intelligent, a lot of times they're well-funded, they're driven, and it puts us in an awkward position as defenders because we have to actually go up against somebody that's got hands on keyboard and knows what they're doing and try to figure out how to at least detect and possibly stop them in their tracks. The next problem is every time we build a new tool, they come up with a new way of getting around it, right? It's a constant chess game. It's cat and mouse. Every time there's a new technique. In 2016, it was all about PowerShell and abusing the built-in tools. For example, we built really great detection tech. They just move past that and start moving on to the next thing, right? So this is good for us if you're in the industry because it keeps us all employed, but it's bad for us because we're a lot of times 1 or 2 steps behind the worst stuff that's out there. So when we start talking about attacks and when we start thinking about how we do really effective security analytics and trying to find these guys, we have to understand that a lot of times these are multi-phase attacks, and probably everybody in this room understands that, we're seeing an attack that unfolds slowly over time, multiple phases. It's usually some sort of commodity malware that comes in and drops and pops a machine, downloads some sort of secondary payload. We're looking at credential theft. Once they've stole the credentials, they can go dark and lay down inside of the network and pivot around. We see a lot of lateral movement. We start playing whack-a-mole and start knocking them off the network. They pop back up again, right? They can go silent, they can go dark, and they move around, and ultimately the goal is, okay, get in, stay entrenched, steal credentials, then steal stuff, and do all of that while doing this, right? If you're an attacker, this is your primary goal. I want to be invisible. I don't want to be detected. I don't want to be seen. I know in a lot of cases there's a team of highly trained professionals that are looking for me, and I want to leave as little of a trace as possible. And given that this is the sort of secondary motivation which enables the first motivation, which is stealing things, in the security industry, we've approached this in sort of the best way that we knew possible, and it was create as much observation as we possibly can, right? So our solution in the security industry over the last couple of decades has been basically, let's build intrusion detection systems, let's tap the network, let's look at the firewall, let's log VPN. In my previous company, let's ingest all the packets, all the PCAP before everything started to go encrypted and actually have a forensic record of what was going on. On the endpoint, we have what we call EDR, where we're recording all the endpoint telemetry, all the process trees, all the registry access, all the netcons. We have IDS, we have AV logs, we have proxy logs. We have intelligence. So once we get all that, we have to layer intelligence over the top of it. And we say, here's the solution, and the solution really winds up looking like this, right? Now we've got tons and tons of data. We've got terabytes of data lying around, and it creates the perfect opportunity for the hackers to go out, start setting off loads of alarms, and slide in underneath when they're actually doing something much more nefarious, right? And so this is actually how I got into the security analytics space back in 2003. Is at IBM. We were working in the commercial SOC at IBM based out of Colorado for our MSS business, and we were getting 200 million IDS alarms a day. Well, what do you do with that, right? We said, we can't hire enough analysts to go through this. We know that the vast majority of them are false positives. We need to be able to support the SOC in a cost-effective manner, and also our customers keep calling us and yelling at us because they're getting popped, right? Because we're not actually detecting the important things. And so this is how I got, and I started working with the Zurich Research Lab, and we started figuring out how can we start applying better analytics to going through these alarms and start sorting through it and figuring out what's important, what's the signal, what's the noise. And then how do we start layering those analytics into the environment so that we can actually catch the bad guys and understand what they're doing and not concentrate on the wrong things. So I've been doing this for about 15 years now, and as this is sort of gelled in my mind, as I've gone through multiple iterations of multiple companies and built multiple different sets of detection and prevention technology, I've come up with this sort of mental paradigm that I call analytics in depth. And everybody in this room, I'm sure, is very familiar with the concept of defense in depth, multiple layers of defense, right? And so as I started building analytics systems, I said, well, I think that we can apply the same paradigm, but twist it a little bit. So when I start talking about analytics in depth, it's the same thing as defense in depth. It's building multiple layers of analytics, but layering them in terms of time as opposed to physical, right? And so I break it out into 3 different tiers, and this informs a lot of the way that I build systems now and when we work with different companies and product teams and et cetera. But we do 3 different types of time constraints when we're actually performing our analytics. So the first one is what I call fast analytics. This is making decisions in split point time. I've observed something, I believe it to be either good or bad, and I make a judgment instantaneously as to whether to let it run, whether to close a network port or whatever, but it happens instantaneously. The second piece is what I call quick analytics. This is where we're actually accumulating state over time. So you can think of those actions that occur where we have multiple phase attacks and things like that. And we're actually making a decision sometimes within the constraints of multiple seconds, multiple minutes, even sometimes multiple hours if we start doing large scale network analysis and accumulating that state. But ultimately, we're looking for patterns and making a decision about whether it's good or bad in a slightly larger context of time. And the last one is what I call deep analytics, and this is really analogous to threat hunting, which is basically get all the data, build a big infrastructure, hire the engineering teams, hire the researchers, and start digging through that data. So to go down one layer on that, when we start talking about the fast analytics, these are things like signatures, right? We have IDS signatures, file signatures, signature-based AV. We also have basic binary classifiers, where binary means 0 or 1. It's either good or it's bad. And we can create classifications that can evaluate in very, very quick time using machine learning and AI models. They take a look at something and classify it good or bad basically instantaneously. And then signatures are still out there, right? For a long time, people say signatures are dead. I say they're not dead. I just think that they are tired, right? They're still useful for contributing signal into an overall analytics infrastructure, so we still keep them around. For a long time, machine learning was pitched as the silver bullet, right? If you listen to the hype, if you go to the big conferences like RSA 5 years ago was all ML. If you do this, it will solve all of your problems. It solves some problems very well, but the reality is it doesn't solve all problems, right? And so once we got past the basic applications of ML, we get into our next silver bullet, which is behavioral analysis, right? And this is where we really get into the realm of what I call quick, right? You don't have to make those snap judgments. You don't have to make a decision in real time. You can take a little bit of time to quote unquote think about it or let the machine think about it. And we get into the realms of like heuristics, right? Like 3 lines makes a point. If I see A and I see B and I see D, then I can alarm, right? The problem is ultimately this is not a silver bullet either, right? It works. It's very good at detecting some things, very bad at detecting other things. It's a very common theme in this. The last one is the threat hunting piece, right? And threat hunting is great, but it comes with its own limitations because it's all about the data, right? This is where, like, if you look at some of the products we build or some of the products I built in the last company, we literally capture everything, right? Or if you have a big SIM environment, you're capturing everything. There's 2 problems with that. A, it's expensive. B, you have to have an engineering team that can manage it. And C, you have to have this dude, right? You have to have the people with the right mindset that can actually go in and use an investigator's mindset to crawl through that data. And it's really hard to find those people, right? And so that's all well and good, but it leaves us with sort of this question of now what, right? Like, thanks, that's a great sort of conceptual overview of how we should maybe start thinking about analytics, but I didn't really propose any answers, right? I've proposed a lot of questions and said there's a lot of things out there. Some of them are good at other things, but not others. And that got me to thinking again, like, well, how do we start building a framework where we can actually go from this, oh shit, we have a problem moment to, okay, let's start methodically building systems that can actually help us solve the problem, right? And so the way that I've started thinking about this is we're all familiar with the Lockheed Martin kill chain, right? This is a great model to start thinking about how do the attackers actually work? How do we classify the different attacks? And then I started thinking, well, if we have the kill chain, can we start thinking about how do we detect the different parts of the kill chain, right? So how do we look at where we are? Everyone in this different room has a different posture when it comes to their analytics environment. We've all got some sort of tech lying around that we're using. We can start looking at it and say, what parts of the kill chain are we good at? What parts of the kill chain are we really bad at? And I'm going to spend a little bit of time talking about the different types of analytics that we can start deploying and where I think that they play well inside of the kill chain. It's important to note this is sort of subjective now, right? We're getting into sort of my experiences and the ways that I've used this. People always say, well, couldn't you do this in this other phase? And the answer is probably yes, right? I'm not proposing to have all the answers, but I am saying this is actually a useful way to start thinking about making purchase decisions or making development decisions, and kind of a framework to, again, to iteratively address the problem of how do we find bad. So the first one, we start off on the fast analytics side, and we can very simply look at signatures, right? We're all familiar with IDS signatures, either Snort or Suricata or whatever. We have file signatures. There's tons and tons of whitelists, by hash, good lists, bad lists, et cetera. And we have the classic IOCs, right? IP addresses, domains, things like this that we can start looking at and actually make snap decisions about, okay, this is something that we at least have some intelligence about, or we've seen it before, and where can we start applying it? So this one's actually really interesting because you can get really good kill chain coverage out of this. You look at all different parts of the kill chain. Weaponization is hard, right? Because that is things that are happening offline outside of our environment. So it's really hard to get any visibility in any of these on that. But signatures, okay, really good breadth of coverage across the kill chain, right? Why don't we just use those? And the answer is, well, the problem with the signatures, you have to have a priori knowledge of what you're looking for. By definition, it's a signature that describes something you know something about. So they're very good at detecting known things. They're very, very bad at detecting 0 days, right? And as with all of these, you'll see another recurring theme is they're prone to false positives. And as we've seen more and more traffic, especially on the wire, going dark due to crypto, which is good, right? We like cryptography, we like encrypted traffic, we like data in flight that's encrypted. These become less and less useful on the IDS side. So they're still out there. I always say, that, like I said, they're tired, they're not dead, but they're certainly by no means going to cover off. Even though we get good coverage on the kill chain, they're not going to solve our problem for us, right? And so when we start thinking about, okay, these are really bad at 0 days, right? So this is where we got into the advent of machine learning, right? Machine learning is a very big term. It's a very overloaded term. I'm going to speak about it specifically right now in terms of binary classifiers, like splitting things into 2 groups, either malicious or benign, training a statistical model that describes what that quote unquote looks like, and then using that to apply to things like files or network traffic or things where you can say, I've never seen this before, but I have a model of what it looks like, so I can take a pretty good guess that if I see one that's new, I can classify it, right? And this is great. I mean, if you take the time to do this, I mean, this takes a little bit of, you have to get people that understand the stats and the models, but there's really good libraries for doing it, or there's good products that do it. You can start splitting these things apart, right? And so the application and the advent of machine learning really found its way in trying to address the 0-day problem, right? How do I classify something that I haven't seen before when I don't have a signature for it or I don't have a hash for it, right? And they worked pretty well at that, but the problem is it's a complicated process. The first thing you have to do when you get into machine learning is a process that we call feature selection or feature engineering. And that's actually taking the time to figure out what the attributes of a given thing are, right? Whether it's a network header or an SSL certificate or a file. And it's iterative, it's time consuming. It's hard to understand what are actually the attributes, say, of a file or of a header and TCP traffic that make it bad, right? And so this is very iterative. You have to hire a team of people that understand both the security domain and the problem domain, and the people that understand the statistical modeling pieces, put those together, and then you can start actually doing this, right? And it can take a long time, but it's tractable, right? And so what we wind up doing, and I've done a lot of this over my career, is you build these teams and you gather a ton of samples, some that are known good, some that are known bad, and you start pulling them apart and figuring out how to featureize whatever the thing is. And you create these training vectors, you feed them through a training algorithm for the different models, you evaluate that, and then you bring in a bunch of unknowns and you can test against it, or actually you can use a bunch of knowns first to see how accurate your model is, and you do that iteratively, right? And so an example that we use to make this a little bit more real is domains that are generated using a domain generation algorithm. This is a pretty well-known example. The model is what we call an SVM. And so it's good at splitting. You basically split the attributes of these domain names into 2 different places, and you're able to classify it by training it. And so if you look at the 2 domains, we have facebook.com, good, right? This other thing, highly suspicious, if not bad, right? And it was created using a domain generation algorithm. And then we say, well, as humans, we can see that, right? So how do we make the machine see that? And so the first thing we do is create the feature set, and we look at the length in characters, the entropy, which is basically randomization, and then we take n-grams, the groups of 3, 4, and 5 letters, and create a distance feature from known words, look from known good dictionary words and known good domains, and then we pull that all out into a vector, and we train up a model, and we say this is what the bad ones look like, and then we test it out, and we figure out how well we did. You know, we call that classification. It falls into the domain of what we call supervised learning, which is basically we're training you explicitly, then we're testing you afterwards. The problem is, while it's good at detecting things that you haven't seen before, we have the output of it is what we call a confusion matrix, right? And it's aptly named because it's basically we have to statistically understand the trade-offs we have between false positives and false negatives, true negatives and true positives, and we map that on the curve here. You see it's called a receiver operating curve, and basically say where do we set the threshold such that we're detecting the things that we want to detect and not missing them, but we're not getting a bunch of false positives, right? And this process takes a lot of time. Anybody who's built these will tell you that it can be somewhat painful, but it is effective. So when we look at the kill chain coverage for this, again, we get pretty good coverage with it. It helps us in our 0-day problem, which is really nice because we can do things and detect, like we have whitelists, we can detect bad files that aren't in the blacklist, et cetera, but they can be very, very falsy. And they're also, if things sort of quote unquote look like each other, it's very easy to confuse it, right? And so again, when ML came to the forefront, a lot of people were trying to build like the Uber classifier, the one classifier to classify them all. We found that that doesn't work very well. And so when we deploy machine learning, we say pick very well-defined concrete tasks and things that you can build very specialized models on and build those and then build a lot of them. So I'm going to go fast because I've only got 35 minutes, so feel free to call me or pull me aside afterwards because I've got a lot of stuff to go through here. So getting past the binary classifiers, we now leave that area of fast analysis and go into the quick analysis and get into the world of behavioral analysis. So again, behavioral analysis is an overloaded term. There's two parts of it. One of them is describing known behaviors and looking for those patterns or those sequences. The other one is, I'll talk about next, is what we call anomaly detection, which is basically training in known behaviors and looking for things that don't fit it, right? And so if we talk about behavioral analysis in the terms of heuristic analysis, we're basically looking for that 3 dots make a line or X dots makes a line where we can say if we see A and B and C, then we're going to raise an alarm. And this, for us in the endpoint world, looks like things like registry access where the keys are obfuscated or some sort of process hollowing or weird invocations where notepad's beaconing out to the network and things like that. And we chain that all together and say, this is a known pattern of bad, right? And then we can create logic over the top of that and deploy that as a detection technique. And so it's handy. In the security world, we have a model to apply to this as well. Everybody knows TTPs, right? Tactics, techniques, and procedures. And as a researcher, a lot of the time that we spend our time doing is understanding what TTPs different attack groups are using, how are they compromising a machine, how are those morphing over time, and understanding how do they manifest themselves either in network traffic or on the endpoint. And then we can code those up and start looking for those patterns in real time when we actually build the monitoring systems. So this is cool. There's a lot of, if you think about SIEM, there's a lot of logic like this in the SIEMs. We built a lot of them into our products, have done it over the past. And we get, again, really good kill chain coverage out of this one, but it sort of has the same problem as signatures, right? If we are looking for patterns of attack, then we can only codify heuristics for things that we've seen before, right? And so now we've sort of come full circle back to this idea of, okay, we can do TTP and we can do heuristic analysis, but we can really only write TTPs for things that we've seen before. And that creates, again, another problem. And so the way that we try to address this in the research community is to up-level these to the extent that's possible, but the trade-off there is, again, false positives versus true positives, right? And so how do we abstract it enough that we can catch things and not be super prescriptive, but not create lots of false positives, right? And so this requires constant update. Anybody who's run a SOC knows this. You have to have an engineering team. You have to have an analyst team that's constantly updating these things. But again, it's very effective as long as you have the horsepower and the manpower to do it. So when we looked at the other side of the behavioral analysis coin, it's like, well, we got back into the problem where we have signatures, basically a meta-signature in terms of a heuristic. Why don't we start kind of going the other way and look at anomaly detection, right? And so this changes us into a realm called unsupervised learning, and we're basically establishing patterns of known behavior, like what's the quote-unquote normal behavior for my network, what's the normal behavior for an endpoint or a user, et cetera. And then we're going to create a baseline off of that, and then we're going to alert when it changes. And so that's what we call anomaly detection, right? And we model in normal, and we highlight and flag abnormal. So this is great. except again, it requires a training pipeline, right? So this is a complicated set of things. You have to have an engineering team, you have to have and engineering, you have to know what to monitor, you have to have the analysts, right? And they have to create this whole training. But it is cool because you basically go through the same featurization process, train up a model where you say for some bucket of time, usually it's 5 minutes or 10 minutes or something, we're going to say what the behavior of the machine was, or the network was, or the user was for that point in time. We're going to build a model over time, and then we're going to flag when it changes, right? And so once you've built the model, then you can start evaluating, you go out of training mode into monitoring mode, and then you can say, okay, this is behaving the way it normally behaves, or this is not behaving the way it normally behaves. So this allows us to detect, without any upfront knowledge, changes in behavior and say this appears to be suspicious. This has its problems as well, because if we collapse this down into 2D space, we start seeing the cluster over here on the left of what's quote unquote normal, and then we start firing things out that are no longer normal based on how far they are from the cluster. And we can do things like, hey, here's a really cool anomalous FTP. We've got a big outbound connection to some place that we've never transferred files before. Let's flag that, that's obvious, right? But the model very quickly falls apart because as we upgrade software, as people move around, if you're like me, you travel a lot, the whole thing blows up, right? And so you basically have this model where it creates a ton of false positives, right? And so we very quickly learned in the industry that anomaly detection it can be helpful in contributing signal, but it's really hard to make decisions about known bad by using just this. Most people I know turn the threshold so high to get rid of the false positives that the people that I've worked say we actually never get any alarms from it because we've tuned it so much that it's basically gone by the wayside for us. So when we map it against the kill chain model, it's interesting because it can be good for doing things like C2 and actions on objectives where you're looking at exfiltration and things like that. So I'm not saying it's of no value, but I'm saying if you're really looking at anomaly detection, be very sort of conscious of what you would be looking for. Otherwise, you really have the ability to slam the sock, right? So it is cool because it can do some zero-day detections. It's good at data theft, which is good. It's also really good, by the way, at finding Bitcoin mining, because if you can build a model and look at utilization and temperature and things like that, it actually works pretty damn well for that. So structural analysis, this is more on the network side, but we start looking at our hosts inside of our network and creating a network topology and say if we're going to map out the network, we can figure out who's talking to who, and then if we can layer in detections over the top, we can kind of predict where we think they're going to move inside of the network. So we call this neighborhood decay, or we called it the crack house theorem at IBM, where basically if somebody gets into the network and starts moving around, the people that they're talking to have a much higher probability of actually being part of some sort of lateral movement exercise. And you can calculate this using things like PageRank, and there's other things like hubs and authorities, and there's a bunch of different graph algorithms that you can apply to this. It is useful, especially if you have hunt teams, is where I found this to be the most useful, where you've got big network graphs. We built a lot of this at ProtectWise, and we could say there's a network of 100,000 nodes. We can start creating heat maps of hot nodes inside of the network and see who they're talking about and guide the hunt teams of where to look next. In the kill chain model, the pros are we can calculate influence, which is really good. Like I said, lateral movement. It's good at C2, and it's really good at doing actions on objective type of work. But again, you're getting to a realm of kind of sophisticated things where you have to have somebody that understands the graph theory, and you have to have the teams that can actually use it. Getting into intelligence, we publish threat intelligence in my current job. I've been a customer and partner of a lot of different intelligence provider. It's all over the place, right? And it's really useful if you add it to, if you create these these analytic suites that I'm talking about, and then you start laying intelligence over the top of it, it can actually help and guide people, right? It can elevate your signal. If you flag something as suspicious and you have intelligence that it's also somebody else is seeing it, you can use it as a +1 on your detection algorithms. But it's certainly, again, it doesn't come for free. There's commercial ones, open source ones. It requires active curation. I have a whole team of people that work in my function that all we do is cultivate whitelist and blacklist, right? It's time intensive, it's valuable. Intelligence, I always think about it just as a different kind of signature, ultimately, right? You're saying this IP is bad, this domain is bad. That's a signature lookup, right? This hash is bad. The problem is these things now tend to be very transient, so the curation piece can be somewhat hard. They do help us. This is actually the only place on the kill chain if you have a sophisticated intelligence group, however, that you can actually look at the weaponization piece, right? And so they're good for, we use it a lot for beaconing. We do it a lot for delivery phase of the kill chain as well, where if you want to shine a light on that and really focus in on those parts of the kill chain, they're good for that. But again, it's really, these things are so transient now with IPs and domains and all the computer generated stuff that it's very hard to track that type of IOC-based intelligence. And the sharing aspect still sucks, right? And so us as an industry, we all need to get better at that. The last piece is, I always close with a word about hunting. It's great. Like, we live and breathe this at Carbon Black. We lived and breathed it at my last company. It's awesome if you can get the data, but the thing to keep in mind, like when you're, like I was just at RSA and it's all hunting, all hunting, all hunting, like that's awesome, but it takes a certain type of person is the first thing, right? We call it an investigator's mindset. It's somebody who can go in and know which thread to pull on and follow that thread and go figure out what's going on and figure out this is something I've never seen before and piece the pieces together. It's also expensive, right? You have to have the right engineering teams, you have to have the right compute, you have to have the right storage. If you can do this, and we work with very sophisticated shops that have the ability to do that, it's awesome. But if you're gonna go down this path, it's good to just go into it with your eyes wide open, right? And so that leads us back to this, which is awesome. You just talked for 30 minutes. Not that helpful. But I think it is actually worth having the conversation. And I've been building detection and prevention things for a long time. And I go out to RSA every year in San Francisco, and it's all the next silver bullet thing. And I look at it and I go, a lot of this is just hype, right? And we all know there's tons of startups, there's tons of big companies, a lot of it's BS, right? And so it's worth us as practitioners in security to understand this is a hard problem. There's a reason all of us are employed. There's a reason all of us do well in this space. There's a reason that it's such a hot industry, and it's because it's really, really hard. And the one thing that I leave with when I give this talk, which usually, by the way, is about an hour and a half, so thanks for taking the very fast version of it, is that as you start thinking about this, that it's actually not as bad as we think, right? If we put a framework around it, and we understand one core concept, and is that it's iterative, and every output, I think the most important thing when I talk to people about this is you have to understand that no matter what, when you talk about security analytics and detection and prevention, that every output is an input to something else, right? So we build these big analytics infrastructures, and we deploy machine learning and behavioral analysis and heuristic analysis but we do it all side by side. And we build what we call hierarchical decision systems, where we take the output of one and create it as input into the other, and those become just another input to make a decision. And if you build those hierarchical expert systems or the heuristic engines on top, ultimately that is an output to an analyst, right? There's no such thing in security as a deterministic detection algorithm. It just doesn't exist. If we invented it, we would all be very, very wealthy, right? And so every output, no matter what kind of analytics or what sort of tech or what kind of tool you're putting in place, the output of that is an input to something, and ultimately that's an input to a human. And the thing when I talk to my analyst is, oh, by the way, you're an input back into the system. This is a constant loop. We're always changing the models, we're always updating the models, either signatures, retraining the classifiers. And so we actually capture feedback from our analysts and say, yeah, this is a true positive, this is a false positive. And we work with the engineering and the security research team to make this a closed loop process, right? So that's a net new sort of mindset for a lot of folks, but it really is. If you start looking at it this way and start thinking, I know that I'm gonna have to post-process everything I do, even if it's a human to feed training back into the system, it's iterative, right? The path it's not a straight line, it's curvy, it's full of pitfalls, but it's solvable, right? I mean, we're never gonna solve it 100%, but we can increase our security posture every day if we think about it in this sort of model. Like, what parts of the kill chain am I good at? What parts of the kill chain do I suck at? What tools do I have? How can I use them more effectively? And then just iterate on it, and ultimately, you'll get better. So feel free to pull me aside. I know I'm out of time. I'm Jay Treinen at Carbon Black. Otherwise, thank you for taking the time to listen. Do we have time for any questions?
We do have time.
Okay, so we do have time for a couple questions.
So anyone have any questions?
You talked about temperature there when you were... Sorry, you talked about temperature on one of the, when you're trying to do your analytics. What do you mean? Are you talking about the physical temperatures of the servers, or?
Yeah, in the Bitcoin mining example, I'm actually talking about monitoring the physical temperature. Yeah, because when you peg something out and run at 100% for long periods of time, the temperature elevates.
Cool.
Yeah.
Thanks.
Thank you. Any other questions? Okay. So thank you. Let's thank Dr. Jim Treinen again, please.
Thank you.